next topic. Okay. So what are those laws? We had a discussion regarding uh, what do you mean by premises or hypothesis. The propositions P1, P2 up to P of n will be said to be premises while defining validity of arguments. We are coming across two terms. One is premises or hypothesis, and the other term is conclusion. Okay. So all those propositions which are coming before therefore word in a statement, all those will be treated as premises. I am giving you hint how to identify which are the premises and which is the conclusion. So whatever comes after therefore will be conclusion. Premises, the proposition Q or capital C, which is logically obtained through the process, is called the conclusion. Okay, what is the process followed in determining the validity of arguments? The process followed is known as deductive reasoning. What this process is? The process of reaching a conclusion from a sequence of prepositions P1, P2 up to P of n. This entire process is known as deductive reasoning. Thereafter, we have seen several laws. Four laws have been discussed in the last class. Those were modus ponens, modus tollens, law of detachment, law of contraposition, disjunctive syllogism, and hypothetical syllogism. Okay. These laws in the theory of logic are known as rules of inference. So let's have a view. So a quick recap of rules of inference. Okay, we had already seen this, and while observing your assignment submissions, I have observed one more thing. That thing is, majority of you have written okay in the symbolic form whatever statements have been given, but you need to follow this format. Okay, format is what you are writing premises above the horizontal line, and you have to write conclusion below the horizontal line. This format should be reflected while solving each and every example of rules of inference. Okay, somebody is asking for entry. So you should follow this format as well. That is my concern. Few of you have followed, few of you are directly written as P conditional Q is true, then P is also true. Therefore, we can reach out at the conclusion Q. Yes, it is obviously fine, but you must mention that P1 is a premise which is stating the preposition in the format P conditional Q. P2 is a premise which is having format only P. And Q is a conclusion which is written after therefore keyword. Therefore, we can represent given set of statements in this format, and thereafter, if these statements, whatever statements given in your example, if they are matching with any of these rules or laws, you can directly say using law of detachment or using modus tollens, etc. The given set of statements is valid. Okay. Sometimes it may not fit, the given example may not fit in any of the existing laws. Then what to do? I have already discussed. If it is not matching with any of the laws, you have to take conjunction of all premises. Okay, premises in the form of conditional or anything that is as mentioned in your example. For example, if we are having two premises P1 and P2, I will take their conjunction. I will make, somebody is saying something, conjunction of premises conditional conclusion. You have to construct a truth table for this, and if we are getting the entries in the last column, the entries for this as all true, if it is a tautology, then we can directly conclude that given set of statements is valid. It is a valid argument. I have received okay several queries, confusions, whatever it may be, from few of you related with determining the validity of example number 3 or example number 1 from assignment number 3. If that particular example is not fitting in any of these laws, okay, I have not discussed yet any law of reduction, I have not yet discussed any inference. I have simply discussed only four laws. And moreover, I said if that is not matching in any of the four laws, you have to use this. Okay. So it is recommended that instead of simplifying the given premises using the laws of logic, you should try to construct a truth table. If it is having 16 values, it is okay. I am not saying that if it is having 32 values or 64 values as such in your truth table, you have to construct the same, but you can limit up to 16 values. The truth table method is the concrete method which is giving us always the correct validity of any argument, which might not be correct if we are using any of the laws of logic. I think in example number 3, you are getting the argument as a valid if you are simplifying the premises, and it will be invalid if you are constructing a truth table or vice versa. I do not know exactly, but recommended practice is constructing a truth table. When to construct a truth table? If it is not matching with any of the laws. So the first law, P conditional Q, is the first premise, and second premise is P. The conclusion is Q. The second, modus tollens, also known as law of contraposition. P conditional Q. Second premise is negation Q. I will have a result as therefore negation of Q. Okay, this one is clear. This one is clear. I have additional laws as well for today's discussion. Okay. The third law, this we have not seen. Okay. Rule of addition. So if we know only one preposition that is acting as a premise, only P is given. So what will be conclusion? As I know, in a disjunction, the entire disjunction will be true if at least one is true. Is it fine? Does it make a sense? In a disjunction, if we are having either of the preposition as a true, then we can assume that entire preposition having connection as a disjunction will be true. So if you have been given a single P, you can conclude that its disjunction with any other preposition Q will also be true. Obviously, if P is true, that P will be available in P or Q. If this is true, I am not at all interested in what is the truth value of Q. It can be either true or false, but my entire statement P or Q will be always true. So this is something new. This law is known as rule of addition. If we have been given a single premise P and we have to compute the conclusion would be P disjuncted with some other preposition Q. I hope this is making a sense. Let us have an example. Suppose we have been given a statement, a set of statements. I will write in other editor, just a moment. Okay. Just a second. Let me start my window. Yeah. So I'm saying, let us say statement given is today is Monday. Therefore, today is Monday, or today is Saturday. For example, I'm saying just okay. Oh, if this statement is given and you have been asked, can you determine whether this argument is valid or not? We can represent this argument using the law of addition, rule of addition. So wherein this today is Monday will act as simple P. Okay. And this therefore today is Monday or today is Saturday will act as P or Q. Obviously, we know that on a single day there can be either Monday or Saturday, but not both. If this is given today is Monday, then your conclusion would be today can be Monday or Saturday, but not both. That is the meaning of this rule of addition. Next is rule of simplification. If we have been given P and Q as true, when this P and Q will be true, P and Q will be true if and only if both are true, that I know. If one is false, then obviously the result is not going to be true. If both are true, then and then only we would have the result P conjunction Q as true. If this is given as a premise, conclusion could be therefore P, or you may write therefore Q as well. I get it. This is fine. Why rule of simplification? If P conditional Q is given, conclusion could be therefore P, or sometimes you may write rule of simplification as if we have been given P conjunction Q as a premise, then therefore its conclusion could be Q as well. I know that if P conjunction Q is true, then P has to be true as well as Q has to be true. This is rule of simplification. Next is rule of conjunction. As I am repeatedly mentioning, P conjunction Q is true if and only if P is true as well as Q is true. In rule of conjunction, we have been given both P and Q as the premises. Both are true, then our result will be if both premises are true, then the conclusion P conjunction Q is true. This is known as rule of conjunction. Is it fine? Shall we proceed? Shall we proceed? Is it fine? Yes. Okay. Fine. Okay. Next, this I have already discussed, the rule of hypothetical syllogism. You have been given two conditionals, P to Q, Q to R. Your conclusion will be P to R. If this holds to be true, this holds to be true, and this has to hold to be true. Somebody might be saying, okay, how sir you can justify this law is correct or not? I have already said that if you want verification, what to do? Take a conjunction of these two premises, take their conditional on the conclusion, construct a truth table and check out that all the values in the last column are all true. That means it is a tautology, and if it is a tautology, it is a valid rule. Rule of disjunctive syllogism, which says that if P or Q holds, negation of P holds. Obviously, it is a fact. Okay, we know that it is given that P or Q is true. In order to have P or Q as a true, I need to have either P as T, Q as T, or both as T. It is further given that P is false. P is false is given, negation of P. Then Q has to be true. That is the conclusion. If we want this P or Q as a true, out of which I know that P is false because of this negation, then what will be result? Q has to be true. This is rule of disjunctive syllogism. I think there are no confusions related with the assignment 3. If any, you can type in the chat window so that I can explain any of the example as per your suitability. I will explain any one. If you want me to explain out of those 10 examples, I will be happy to discuss the same. Otherwise, I will move on towards the next one. Do you have any doubt in assignment number 3? Shall we proceed? If you are not having any doubt, don't you have any doubt? Explain one example. Which example? Question 1 should I explain? Okay, no problem. First question I will explain. Okay. That I was asking. Okay, all are saying question 1. Okay. Okay. No problem. First, in fact, if you ask me for solving all 10, I am ready for solving all 10, but it will require a suitable amount of time. Okay, and that time is not available with us. Considering your entire syllabus. So where is my assignment? I posted that assignment. This one, I guess. PKVAT DM3. Okay. What was that assignment? Let me check out. Just a moment. Okay. Give me a moment. Okay. Let me check. Yeah, this is awesome. Look, many of you are having confusion. Confusion meaning I think you were not able to place this in any of the laws, and that was your main confusion. I could learn. Okay. From many of the queries. So what is given? If today is Friday, then there is a lecture of OOP or DM. If OP teacher is sick, there will be no lecture of OP. Today is Friday and teacher of OP is sick, therefore there will be lecture of DM. Okay. So let. I think this is visible properly. Okay. In case it is not visible, let me. P denote a preposition which says today is Friday. Q denote a preposition which says it is mentioned. Look. Okay, let me try to give it my way. Okay, no problem. There is the R denote a preposition. There is the okay. Moreover, it is given S. There is OP teacher is sick. I have again observed that many of the students are trying to write the entire statement as a single preposition. Please do not do that. It will create an ambiguity. It will create a confusion in your mind. I was not sure, but I was going through the assignment solutions today morning, and I have seen one student has mentioned that let P be a preposition which says if today is a Friday, then there is a lecture of OP or DM. You are entirely stating a single statement, okay, as a single preposition. That may or may not happen in each and every example. Okay. So let us try to represent the given information in this format. We are having now four prepositions, four different prepositions. Okay. So first one is given if today is Friday, then there is lecture of OP or there is a lecture of DM. This is known as premise 1. Next, it is given that OP teacher is sick, I guess. Okay, what is given? If OP teacher is sick, there will be no lecture of OP. The second premise. It is not compulsory that you are going to have only two premises. You may have n different premises on n prepositional variables. Okay. In our first example, we are having too many premises. So what is the other? If OP teacher is sick, there will be no lecture of OOP. OP teacher is sick, S. Then there will be no lecture of OOP. Negation of Q. P2. Third, today is Friday and teacher of OP is sick. That is the third. Today is Friday and teacher of OP is sick. Who is teacher of OP? S. This is premise number 3. And then I'm going further. I have encountered a therefore keyword. So therefore, there will be lecture of discrete mathematics. That is the conclusion. Okay. Lecture of discrete mathematics meaning R. And this R will be treated as a conclusion. Okay. These are the things that are available with you. Okay. The one method is simplification. You can go on simplifying this because if you are observing, there are 1, 2, 3, and 4 prepositions. If I am using a truth table method, I will require 16 values in the truth table. Okay. And otherwise, I can try for simplifying this, and I can try to place these statements in any of the laws that we have discussed so far. Okay. So let us try for both of the approaches. Truth table I am not going to construct, but I will try for simplification. Okay, how can we simplify it? So, recently we have seen there exists a law of conjunction. What that law of conjunction says, if we have been given P conjunction yes, we can represent the T conjunction yes as P or as yes. Is it fine? Whether the pace is fine? Yes, I'm sorry first one. Whether the pace is fine? Yes. So, okay. Pace is fine. Okay. So, okay, what can I do? I have to simplify it so that the same can be represented using any of the existing laws. So we know that P conditional Q can be represented as negation of P or Q. So the first premise I am representing negation of P or Q or R. Second, I know that again, I will say this is negation of S or negation of Q. The third one, P and S, I will use any of the existing. Okay. So let me write here P. Okay. Next, we are again observing this one is negation of P or Q or R. This one is, let us again simplify this. I am keeping conclusion as it is. Okay. So again, I have recently observed law of disjunction. If something is false, the other one has to be true. So how can we represent negation of P or Q or R? Any replies in the chat window? How can we represent negation of P or Q or R? Q or R. Otherwise saying Q or R. Okay. Okay. How about this? We are having one law. Which is that law? It says negation of S or negation of Q. I will say it is S. For making it simpler, nothing else. Further to this, okay. Check out if we can place this in any of the laws. Can we place PPQ or R? Okay. Okay. Now be careful what I am saying. I have first of all simplified it in the form of conjunction or disjunction. Now be careful. Okay, if anything is not clear, let me know. Moreover, I have further used the law of disjunction and I have taken only Q or R. Then I have used here De Morgan's law. Negation is coming outside. Inside this, we are having S conjunction Q and we have kept P as it is. Okay. So Q or R will be true when Q or R will be true if either Q is true or R is true or both of them are true. Am I clear? This will be true if this one is true or this one is true or both of them are true. Our second premise is saying what? S is false as well as Q is false because negation is present. S is false as well as Q is false. So in first premise, if I want Q or R as true, Q or R as true, out of which Q is given as false, then what is my conclusion? R has to be true. Okay. We are not interested in this P. P is true. P is true. Meaning of negation is this entire statement is false. This entire statement is false means what? Either S is false or Q is false. If Q is false, then this is making contradiction with Q or R being a true. If we want Q or R as a true, and out of which if Q is false, then R has to be true. If Q is false, R has to be true. Whether my Q is false, okay, whether my Q is false, Q will be false if we are taking, yes, if we are keeping this P and S as it is, okay, here. If we are keeping here P and S as it is, I come to know that today is Friday as well as OOP teacher is sick. In order to have P and S as true, I need P to be true as well as S to be true. Okay, simplify. Let us not simplify this. It is creating confusion to you. Let us keep this P and S as it is. Okay. This P and S, if I want P and S as a true, I need to have P as true as well as S as true. Okay. S need to be true. So if S need to be true, then what should be false in this statement? Q has to be false. If Q is false, okay, then in order to have Q or R as true, I need to have R as true. So what is my conclusion? R is true. That is the conclusion. Are you getting? What is our first assumption? First assumption is we have simplified this to Q or R using the law of disjunction. Then, okay, I have applied De Morgan's law over here. If you don't want De Morgan's law, then also it is fine. Okay, you can look for this. And further to this, we are having third premise as P conjunction S. Now, in order to have but confusion is okay. Still, you will have confusion in your mind. Why I am taking like this? You know that what is the definition of valid argument? Conjunction of premises, conditional conclusion has to be true. Okay. So, if you want this statement as a true, okay. If I want this statement as a true, which is negation. Okay, if I want this statement as a true, this statement S conditional Q, entire negation of S conditional Q as a true, okay, negation true pahije. In that case, I must have S conjunction Q as false. And when this S conjunction Q will be false, we know that P conjunction S is already true. That means S is true. Q has to be false in order to have S conjunction Q as a false. False opposite is true. So Q is false. Obviously, R has to be true in order to have this as a true. So what is my conclusion? R, a true, is a conclusion. I hope this is clear. If this will happen only with practice, okay. We are at the first stage of solving these examples. As you practice more and more, the things will get clear. Okay. Otherwise, my suggestion is, if the things are not clear, no problem at all. What to do? Simply construct a truth table of all 16 values and check out whether the final column is a tautology or not. It will also give you the same marks. Only the time required will be more, nothing else. Is it fine? Silence in the class. Okay. I cannot see your eyes. That is the only drawback of online teaching. I cannot read your faces whether you are getting or not. Do not say yes only for the sake of saying yes. You should be saying yes with your heart, with your mind, not for the sake of saying yes, not for attending the lectures. समजलं तरच हो म्हणावं, नाहीतर नाही म्हटलं तरी काही हरकत नाही. नो कंपल्शन. वाटेल. ठीक आहे. Moving further, so if I discuss these laws, what is next on this? Okay, I will come to that quantification shortly. Before that, okay, I do have again few examples. Okay, so observe, I am going to discuss this mathematical reasoning concept shortly. We will be using reasoning, mathematical reasoning, to determine whether the arguments are correct or incorrect. This reasoning is important for artificial intelligence. You might have heard this. Our college is also having a new branch from this academic year, artificial intelligence and data science. Okay. So what artificial intelligence is? Artificial intelligence is a technique which, okay, makes a computer intelligent, wherein a computer can take decisions based on the facts. A computer can reach to a conclusion from knowledge or the facts. It is resembling human mankind with the machines. That is branch of artificial intelligence. Okay. In that you will require such a reasoning practices. So this reasoning is important. Some may have a question in mind. Why we are learning this? We are learning this to make a computer more intelligent, to make computer to solve our problems on its own and give us the solution. We can use a proof to demonstrate that a particular statement is true. A proof consists of sequence of statements that form an argument. I have already discussed this. So what are rules of inference? Inference is the act, inference also known as deduction, is the act or process of deriving a conclusion based on what one already knows. It uses hypotheses, axioms, definitions to reach a conclusion. Same practice is followed by human brain as well. If you know certain facts, you could arrive at a certain conclusion based on those facts, obviously. Huh? So you are making use of rules of inferences. This is quite good in quantitative aptitude as well, or wherever there is a existence of reasoning part, you will observe these rules of inference. Okay. So general form of rule of inference is this one: premises and conclusion. So P to Q, P conclusion. This is already discussed. I am not going to discuss. These are the slides that I will be sharing with all of you. Okay, no problem. So first question for you. Again a practice. If whenever all its hypotheses are true, its conclusion is also true, then only we are saying an argument as a valid. Check whether the following argument is valid or not. If it rains today, then we will not have a barbecue today. If we do not have it today, then we are going to have it tomorrow. Therefore, if it rains today, then we will have a barbecue tomorrow. My question is, can you relate this with any of the existing laws and tell me whether this statement is valid or not? Valid. Abhishek is directly saying valid. Okay. Which law you have used, Abhishek? Which law? If it rains today, then we will not have a barbecue today. If we do not have a barbecue today, then we will have it tomorrow. Which law? Law 4, hypothetical syllogism. Very nice. Okay. The answer is in front of you. P is it is raining today. Q is we will not have. I is we will have. Argument is of the following form. What is the form? P to Q, Q to R. So my conclusion is P to R. In this case, there is no need of constructing a truth table or mentioning that this is true, hence this has to be true. Directly by using the law, we can conclude. Can you check for this? Gary is either intelligent or good actor. If Gary is intelligent, then he can count from 1 to 10. Gary can only count from 1 to 3. Therefore, Gary is a good actor. Can anyone tell me the answer for this Gary? Whether Gary is good actor? Whether it is correct or incorrect? Okay, read out. Gary is intelligent or good actor. So for that case, we will say I would say here for intelligent, let us say I. or A. Intelligent or actor. If Gary is intelligent, so intelligent असेल तर, if that is the case, then he can count from 1 to 10, and moreover it is given that he is counting from 1 to 3, and conclusion is Gary is good actor. So this has to be given as indication. So what is your conclusion? Whether this is valid? Rohan is saying valid. Abhishek Khamkar is also saying valid. Shubhangi is also saying valid. Okay, Neha, valid. Using which law? Using which law? Does it fit in any of the existing laws? Anurag is saying discrete mathematics. What? What discrete mathematics? Anurag Bruce Lee. Okay. Whether there is any law known as discrete mathematics? Anurag. Shubhangi is saying disjunctive. Disjunctive. Is it? Disjunctive. Valid using disjunctive syllogism. Vaibhav. Okay. Very nice. Yes, sir. So how can we represent this? This is valid. Perfectly fine. How? Let I denote Gary is intelligent. A denote Gary is good actor. C denote Gary can count from 1 to 10. So first premise, A or I. Second premise, if intelligent, then count from 1 to 10. Third premise, negation C. So conclusion is actor. So by using disjunctive syllogism, first of all you need to convert this I to C into proper form. So what will be proper format of this I to C? Negation of I or C. That will be proper form. Okay, then using law of disjunction, I could conclude, okay, if this is negation of I or C, okay, in order to have A or I as true, and out of which I is false, negation of I, that's why I is false, then I need to have A as a true. So if A is a true, then only we can reach out at this conclusion. Gary is a good actor. I hope the things are clear. Okay. Using disjunctive syllogism. Fine. Any further doubts? No doubt. Okay. Moving ahead, as we have already seen, we can make use of various quantifiers like universal quantifier or existential quantifier for representing more than one object in the preposition using predicate. So rules of inference are also applicable for those laws as well. So we are going to discuss now what are the various rules of inference which are applicable for the quantifiers. These were the simplified rules of inference. Now for quantifiers. So quantified statements. The first rule, known as universal instantiation. Suggestion is take a snapshot of the slide. Okay. So first says that if there are two premises, first premise is for all x belonging to certain domain D, if it is known that predicate P of x is true, and there exists, okay, some small d, some instance which is also a member of domain D, then what is the conclusion? P of D will be true. I will take an example of each so that things will be clear. Okay. If it is known that for all x, P of x is true, then predicate P is true for certain value of D which is present in original domain D. Other rule of inference, universal generalization. If we know that P of D is true for any value of D belonging to D, then our conclusion will be for all values of x belonging to capital D, P of x will be true. Reverse of this. Meaning is self-explanatory. Third one, existential instantiation. If there exists x belongs to D such that P of X is true, your conclusion will be P of D for some value of D will be true. It is not true for all values. Okay. Alternative generalization. If it is known that P of D is true for some small d belong to capital D, the conclusion will be there exists a X for which P of X is true. I hope this is making a sense. Does it make a sense? I don't know. Okay, if it is making a sense or not. Okay, can you reply? Okay, have you taken this? We are going to consider few examples on this. Okay. Your things will get clear for sure. Okay, so let me have something for you. Okay. Okay, let me share a copy. So rules of inference for quantified statements, those four plus the fifth one that I am discussing now. So universal modus ponens, what this says, for all x, if we have p of x, sorry, conditional q of x, these are the predicates, that is the reason why I have written in capital. For all x, if we know that first premise is for all x, p of x conditional q of x is true, and second premise is p of a is true. A is some element in the domain, okay, for which p of a is true. So what is the conclusion? If we know that for all x, p of x given q of x is true as well as p of a is true, our conclusion will be q of a is, are you getting my point? Okay. This law is known as universal modus ponens. Okay. Is it fine? If you know that for all x, p of x gives q of x is true and p of a is true, your conclusion will be q of a is true. Why this has to be true? If this is false, then this will be false. And if we know that first one is true, then second one has to be true in order to have this entire conditional as true. So our result is q of a is also true if this p of a is true. Does it make a sense? Whether all are present? All are present? Can you reply in chat box? Yes. Okay. 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 Fine. If I slightly change this, okay, if I know that premise is for all x, p of x gives q of x, and second one is negation of p, a. What will be its conclusion now? If it is negation of p of a, what will be conclusion? Okay, instead of negation of p of a, let me write negation of q of a. So this one is negation of q of a. So now can you tell me what will be conclusion? If this is not, if second one is false, okay, what should be first one? See, you have to now think logically. We want this as a true, this entire thing as a true. For having this entire thing as a true, my q of a will be false. That means this q of x will be false. If I want this entire thing as a true, my p of a must be false. If it is true, my entire thing will not be true. Negation of, very nice, negation of p. You should know now how this negation of P of A is coming. That is the reason why I was asking you. Why this is not P of A and why this is negation of P of. Am I clear? Very good. Okay. So a few examples before we conclude for today. Yeah, negation of P. Good, good, good. So example number 1, all FE students knows C programming. You are not knowing C programming, isn't it? So I will say Python program, but not about C because syllabus is changed, isn't it? Viraj is student of FE. Therefore, Viraj knows Python programming. Whether it is valid or invalid, that is the question. Valid. Using which law? Using which law? The very first law that we have seen. What is that law? For all x. What is P of x? That you should write in exam. Okay. P of x is? What is P of x? X is a student of first year. That is P of x. P of x denote the predicate x is a student of first year. Let Q of x denote a predicate x knows Python programming. This is given. So how can I represent this first statement? All FE students knows Python programming. For all x, if student is of FE, then he knows Python programming. For all x, P of x, conditional Q of x. What is second? Viraj is a student of first year. This is specific. P of Viraj. So what is your conclusion? If this is the thing, conclusion has to be Q of Viraj. So what is Q of Viraj? Viraj knows Python programming. Hence the given set of arguments is valid. Am I clear? In the similar manner, can you tell me the answer for second? Okay, can you tell me the answer for second? Second one. Next one be a statement. Let me write here second so that we will not confuse. All my friends are musicians. S2 be a statement which says Sonal is my friend. S3 be a statement which says none of my neighbors are musicians. Okay. And let's see, be a conclusion. Kunal is not my neighbor. You have to determine whether this argument is valid or invalid. Again, by which law? Abhishek, it is valid. Yes, it is valid. But by which law? How can you justify it is valid? Law of contraposition. See, now we have to use in terms of quantification, okay? Because I am observing all is used, so there will be usage of quantification. So see how to solve this. It is valid. Obviously, it is valid. Perfectly fine. Okay. How can we represent S1? For all x in bracket f of x conditional m of x. What this denote? All my friends are musicians. F of x be a predicate which denotes x is my friend. M of x denote a predicate x is a musician. for S1 for all x f of x. If it is a friend, it is a musician. S2. Kunal is my friend. F of Kunal. Directly, we are specific. Okay, f of Kunal. S3. None of my neighbors are musicians. It's what? The right x. Okay. If it is none of, then we are using condition. N of x denote a predicate where x is a neighbor. Okay. If x is a neighbor, then he or she is not a musician. These are the statements given. And what is the conclusion? Conclusion is Kunal is not my neighbor. Negation of N of and you have to now tell the validity. Okay. So while telling the validity, okay, we will we want what? This conclusion has to be true. In order to have conclusion as a true, N of Kunal should be false. If this is false, then its negation will be true. So N of Kunal, if you want N of Kunal as a true, okay. If you are saying N of Kunal has to be true, then here, okay, if N of Kunal is true, then he will not be musician. That means Kunal is your friend, and it is again, okay. Here you have to say all these premises should be true along with conclusion in order to be the entire statement as true. मला सगळे true पाहिजे. Okay, I want all as true. So how can I say in order to have all these true? Okay, the first statement should be true. At the same time, second should be true. In order to say friend of Kunal is true, Kunal is friend. Okay, this is true. In order to have this as a true, we are observing that this is negation of m of x. So I should have here true, sorry, false. M of x should be false so that its negation will come true, and I will have this entire set as a true. So finally, I reach out to the conclusion that Kunal is not my neighbor is true using the contradiction and simplification. I'm coming to know that this is going to create some sort of confusion in your mind. So you can take this as a homework for thinking. You can discuss it with me. Okay. In the meantime, I will provide you the detailed solution during the next lecture. Till the time, just take a snapshot of this and try to validate how this argument is valid or invalid. Is it fine? All of us know that this is valid, but we need to justify properly. So take a snapshot and try to write your conclusions, justifications properly. I have given you a hint. We want all these true. Along with that, we want this as a true. Based on that, you can write. Okay. Fine. So, okay. Before we stop for today, you can again turn on your cams. You will have your attendance, and thereafter we will stop. So turn on your cams. I'm waiting for your cams to turn on. Can you turn on your cams? No. I audible? Yes. Okay. Turn it on. Be fast. Only Prathamesh has turned on. Okay. How about others? You are not having bandwidth? Okay. Who is this? Abhishek. Then Anuraj. Then Sunny. So, then who else? Some activity after turning the cam on. The usual activity. Those who have not submitted the assignment, okay, do it as early as possible. Now you can leave this meeting. Thank you for that. Have a good day.